Hi, my name's Tom Taylor, and I'm the owner and president of Taylor's Nailers. We are a local San Francisco Bay Area remodeling and general contracting firm that specializes in energy designs to save your resources and our planet. I'm standing in front of one of the most efficient combination radiant heating and hot water heating units. This is a combination dual unit that provides people both hot water and heating throughout their units. This is what's known as the manifold. The manifold distributes the water, the hot water, to the radiant system. As you go up, the radiant system is pumped up into the different zones or floors. This unit has just one zone for each floor. You can see that as it goes up and it passes through a number of pipes, and it goes and it's distributed to the different PEX types of radiant distribution systems. So because the water is recirculated, it's very dense type of energy, and it is very, very efficient. When it's heated only to about 120 degrees. So one of the chief advantages of a system like this compared to the old steam heat systems is that you avoid what's known as phase change. That's when you have to heat the water all the way up to 200 degrees in order to turn it into steam. With a radiant boiler system, all you have to heat the water up to is 120. So there's a big energy savings there. The other advantage with radiant boiler systems is that they use water as the medium to transport the heat. Water stores heat very well. So with the system, we've got a pump that pushes the water from the boiler system into this what's known as heat exchanger. So in this case, it comes into the block and then comes out and then goes back in. On this side, this is the domestic hot water. So the water is pushed in via this pump over here, and then it's pushed back into the storage tank, and the two waters are never commingled to prevent contamination. So one of the advantages of one of these efficient heating units is that it puts out very little heat. That means that you can have an exhaust out of PVC and not be worried about fire or any kind of combustion. So here we have the control unit for all the different pumps. This will turn on these as necessary. They have a temperature sensor inside them and controls the pump action and turning it on and off. So what we have here is the supply line that comes down from down below to the heating unit, and it goes up to the individual floors. This building happens to have 4 floors that we're heating, and so you can see that there's 2 individual floors being heated with these 2 lines. You have a supply line and then you have a return line. And the copper comes to the PEX, and there's a compression fitting there, and then it goes on up to a distribution area. Now you can make different zones if you like within a single floor. Some people like to zone the bedrooms differently than the living rooms. That's a choice. It just adds to the complexity of the project. So you can see as we go up that it goes from a single feed on up to an octopus of different branch feeds, and it can be very complicated. So what we have here is the PEX tube. It's a red plastic polyethylene tube that runs throughout the joist bays. This allows the water to flow evenly and disperse the heat via these fins right here. They radiate the heat. The PEX is fastened to the subfloor with a block in order to hold it off that subfloor and allow the tube to heat up and expand and contract and not rattle when it touches the bottom of the floor. So then the insulation goes up over that, and it will help to radiate the heat up and give a very comfortable heat for your floor. We're at one of the rough in finish stages. What we have right now is we have a series of radiant pipes running throughout the floor. That's going to distribute the heat from the radiant boiler that we saw downstairs. We're now currently pouring a self-leveling concrete product called Gypcrete over the pipes. This will actually serve as a moderator for the heat that comes through the pipes, and it will also serve to create a substrate for the wood that will go on top of it, the finished floor on top. It's a self-leveling product. It will seek its own level, and they use a tamp in order to level it all out to a very nice finish. You'll also see that in some places there's some nails set in the floor. Those establish the levels of the floor of the product to make sure that the floor is dead level. So it's a very efficient product, and it's a very forgiving product as well. So this is one of the three ways of distributing the heat from a radiant boiler system. There's in the joist bay, there's in the concrete, and then this third way, which is with a radiator. So here we are looking at a radiant baseboard. You can see that there is a series of vanes, aluminum fins, that help distribute the heat. So the water's traveling along here. It's hot when it comes in, hits these vanes, they're aluminum, and that distributes the heat. And then it comes out and it passes and it recirculates back down to the boiler downstairs. The baseboard is the most cost efficient, but it also tends to be the most localized. In the concrete is probably the most efficient in terms of distributing heat, and it tends to be the most disruptive. So this has been an overview of a very efficient hot water and radiant boiler heating system. So if you're concerned about the environment or simply want to save money on your energy bills, please contact me, Tom Taylor, at Taylor's Nailers.